Hi everyone, today we want to tell you how we created our project, Simetec.
It all started when our school updates its programs to mechatronics.
Yeah, the old workshop were mostly focused on traditional machinery.
And we realized there was a huge technical gap in our laboratories.
Students need to learn about PLC, advanced pneumatic, and industrial sensors.
But the main issue was that commercial training modules are super expensive.
Exactly. Most of school just can't afford the multiple units for everyone.
Because of that, we often have to really only computer simulation.
Which is helpful, but it's not the same as touching the real hardware.
So we decided to solve that problem and close the gap ourselves.
We wanted to design a training station that was portable and accessible.
A cool system that combined mechanics, data controls, and electronics.
And that's exactly the idea of using Simetec came up.
We designed it specifically to improve our technical and practical skills.
It's basically a system on wheels.
The goal is that no students graduated without using real industrial equipment.
We wanted to make the most out of practical learning at our school.
Since it's portable, teachers can easily move it into any classroom.
This fixes the problem of limited space and low school budgets.
It turns a regular classroom into an automation lab in just minutes.
Let's talk about the brain of the project. What controller did we choose?
We picked the Siemens logo PLC, specifically the 24RCE model.
It's an excellent programmable logic controller for schools and industries.
It allows students to program logic directly on its small screen.
Or they can connect it to a computer using an Ethernet cable for advanced codes.
It's a very versatile device that supports functions, blocks, and ladder diagrams.
In this way, students learn programming languages that are used in real factories.
The PLC process all the data and coordinates the actuators.
Its strong designs guarantees it can handle daily use in the workshops.
It's the base that connects all the technologies of Siemens.
What about the power supply? How is the electrical part organized?
We designed a dual electrical system to handle different power levels safely.
Yes, we use 24 volts DC lines for the internal logic and sensors.
But the model also handles three-phase AC power for heavier components.
Managing both types of energy is standard for the industry.
Thanks to this, students get a very realistic industrial wiring experience.
Exactly. They learn how to separate different high voltage power from different lines.
Which is a fundamental technical skill for any mechatronics students.
This prepares them to face real-world scenarios and find electrical faults.
Plus, it helps them lose the fear of manage the high voltage.
Moving on the mechanical side, we decided to add a pneumatic system.
That's right. We included double signal cylinders and standard valves.
This electromagnetic system is directly controlled by the PLC outputs.
Students can program complex sequences to extend and retract the pistons.
And we also add industrial proximity sensors to the mix, right?
Correct. We install high precision inductive and capacitive sensor in strategic spots.
These sensors detect metallic objects as they move along the station.
So the PLC gets a digital input signal every time a piece arrives.
And then it triggers the pneumatic actuators to move or sort that piece.
It creates a perfect loop of data input, logical processing, and physical output.
On this part, we also include a super important device, a variable frequency drive or VFD.
That was a crucial addition to control the speed of the motor accurately.
The UVFD is directly connected to a three-phase induction motor.
And that motor is responsible for moving a conveyor belt we built ourselves.
Frequency drives are used everywhere in the industry nowadays to save energy.
True, and also to control the smooth of acceleration and deceleration ramps.
Students can program the VFD to change the belt's direction.
Or they can change the speed automatically based on sensor readings.
That adds another interesting layer of mechatronic complexity to Simetec.
It perfectly connects digital electronics with heavy metal machines.
User safety was our top priority during the entire development.
Of course, you can work with three phases power without proper protections.
We integrated a big visible mushroom style emergency stop button.
When you press it, it instantly cuts all power to the motors and actuators.
We also include circuit breakers to protect the system for overloads.
And motor switches to prevent any damage from overheating.
If a student makes a mistake while wiring, the protection strips immediately.
This keeps the student safe and protects the school's expensive equipment.
Learning safety rules is just as important as learning how to code.
In the industrial sector, safety compliance is absolutely not negotiable.
How did we manage to coordinate and build this prototype from scratch?
We strictly followed an engineering methodology divided in 5 phases.
Phase 1 was about virtual design and simulating circuits in software.
We used programs like FitSimu and CADSimu to check connection first.
That saves us a lot of time and prevent us from damaging to real components.
Phase 2. Phase 2 was buying materials and checking technical datasheets.
Phase number 3, development of electrical system and PLC programming.
After that, we moved to phase, which included mechanical assembly.
We cut materials, mounted DIN rods, and organized air pipes.
And finally, phase 5 consists of strict operational and calibration tests.
In conclusion, Simetec bridged the gap to modern Industry 4.0.
It prepares students to be highly competitive in the job markets.
We are very proud to present this finished working prototype today.
We want to thank our high school for giving us the perfect environment to grow.
And a very special thanks to our project advisors, Dr. Rosa and Dr. Oscar.
Their valuable device advice and expert guidance crucial to succeed.
Thank you so much for your time and your attention today.
We are now ready to start with the live demonstration of the system.
We hope you find it interesting and useful for future generations.
Thank you to all, and we are open to any question and useful for the future.
Bye.